Here we go with I can write and solve multi-step inequalities. Number one, how I treat all of these is just as if they had an equal sign, and I do the left side, I do the right side. So, and just like with an equation, I look at this and I say I have 1, 2, 3 options for how I can rearrange this. And what I'm looking at is I'm thinking, you know what? I'm going to move this 4 over because that way I will then technically have my t's, my variables on one side already. So there's that. I have 10 is less than or equal to negative 5t. And then now I'm going to divide by negative 5. And what's going to happen is the t is now over here all by itself. This is negative 2. And then something important happens. This flips because we have chosen, and by the way, you didn't see it, but just right now I just poked myself in the chest and I said, we decided to divide or multiply by a negative. Now, I'm not going to stop there. I just prefer to put my variable on the left side. So what that means is I'm going to flip everything around. So the t is now on the left. This flips. And if you're like, well, wait, why does that flip? Well, it's because I just literally chose to reverse the entire equation, or actually the inequality. So the logic is still the same. Negative 2 is greater than t. Negative 2 is bigger than t, but usually we read it left to right, so t is now less than negative 2. And no, I did not say less than or greater or equal to, but that's okay. You don't have to say it every time, and now we shall graph it. So here is my number line, 0, negative 2, and 2, just for good measure. I will put a filled in dot on negative 2, fill it in there, and then I'm going to shade to the left of it. Why to the left? Well, for 2 reasons. Number one, t is all of the numbers that are smaller than negative 2. So all the numbers this way are smaller than negative 2. And then, yes, also my stupid way of remembering this is if you have your variable on the left, this becomes like just an arrow, and you shade towards that arrow. So keep in mind, it has to be on the left. That is also my stupid way. I would rather you understand that it's all numbers less than or equal to negative 2. All right, number 2. You have choices. You have one choice that you could multiply by 4. You have a second choice you could subtract by 2. You have a third choice that you could subtract by 3, but it just doesn't make as much sense. So I'm going to show you 2 ways that this one can be done, because I had a question in class where they said, hey, I multiplied by 4. And I said, hey, that's a good idea. You can multiply by 4. And here's what they did. They multiplied by 4 right there and right there. Oops. You need to actually multiply the entire side by 4. It might seem like, well, why would you have to do that? But that's essentially what is happening when you multiply by 4. So multiplying by 4, you're going to distribute. And yes, that 4 will cancel that 4, giving you m. But now you still multiply that 4 by that 2, and you get 8 is less than 12. You subtract 8 to get m is less than 4. Now, I'm going to do it the other way that you might have thought to do first, and you might prefer to do first. It's up to you which you prefer. Subtract 2, and you get 1. Now multiply by 4, and either way you get m is less than 4. Okie dokie. Now to graph this thing, here's 0, here's 4. Why don't I put an 8 on there? I like to do 3 numbers sometimes. Anyway, I'm going to put an open circle on 4 because I do not actually hit 4. If I did, there would be an equal to sign here. And now I will shade to the left because it is all of the numbers, m is all of the numbers that are smaller than, less than 4. 0 is smaller than 4. And yes, again, my stupid way to remember it is if your variable's on the left, this is an arrow pointing to the left. So boom, there you go. I did number 3 in class, but let's go ahead and do it in case you were asleep or you missed it. I'm going to subtract 5. We have negative 3. I'm going to multiply by -2. And I need you to remember that we will flip this because we chose to divide or multiply by a negative. And now we can graph it. 0, 6, -6. Let's put an open dot on 6, but then because of the equal to part, we're going to fill it in. And then now we're going to shade to the left because all of the numbers smaller than 6 work out for this. Number 4, I'm going to subtract 7. I'm going to multiply by -6. And here comes my graph. Switching colors because I like to do that. Open circle all of the numbers that are bigger than -24. So this is an open circle, right? Open circle, not filled in. Number 5. A little bit of simplifying before we start. And I guess, you know what, I'll do this one a couple different ways because, like I said, you have some options of how you can solve these. Okay, so here's one, here's another. Okay, I want to divide this whole side by -2. Oops, that was multiplying. So I get -2 because 4 divided by -2 is -2. Flip my inequality because I chose to divide by a negative. And on the right side, we just have y plus 3. I'm going to subtract 3 and I get this, okay? On the right side, what I could do is distribute that -2, and I get 4 is less than -2y minus 6. I add the 6 to get 10. I divide by -2 to get -5 is, and again, we flip the inequality like that. So either way, this is what we wind up with, right? And then, as I said on number 1, I just prefer to switch these around because of just how it reads. Like, I don't like to read this -5 is greater than y. -5 is greater than all of these numbers. Well, okay, it just feels a little bit better to me to flip the whole thing around. Y is smaller than, is less than -5. And then in reading that, y is all of the numbers that are smaller than -5. Open dot, shade to the left. Number 6. I'm going to divide by 6. Again, yes, you could distribute that, and you would get 24, 6w minus 12, but you're going to end up the same way. I'm going to add 2. Again, I just prefer to rearrange it to be w is less than or equal to 6. And here comes the graph, 0, -6, 6. I'm going to put a filled in circle on 6. Why? Because of the equal to part. Make sure I didn't, sometimes that's easy to forget, so I just went back to make sure I didn't forget that there. And now I'm going to shade left because it's all of the numbers that are smaller than 6. And in fact, well, how could I check that? I know you're not really thinking that, but take a number, plug it in. How about 0? Is 0 smaller than 6? It sure is. That's why it is being shaded, okay? Over here is 10. Is 10 smaller than 6? No, and that's why we don't shade over here. Number 7, we got to do a little bit of simplifying before we can solve this. Actually, maybe not simplifying. What we're going to do is move things all to whichever side we want to move them. So I'm going to subtract 7 in. You had lots of choices. That's just the one I chose, okay? Now I'm going to add 4, divide by -12. And then just keep in mind, this switched because we divided by a negative. Now the graph looks like this. 0, -2, open dot on -2, and it's all of the numbers that are less than -2. Number 8 is going to have a special case. So let's check it out. First thing is I'm going to combine these two. This one we really do simplify before we start solving. the left side doesn't change. The right side becomes like that. And you might like have taken the fact that I said this is special and the fact that there's a 4K on both sides and are seeing, wait a second, those are going to cancel each other out, and I end up getting that. -6 is less than -1. Is that okay? Yes, it's very okay because this is a true statement. I mean, actually, any time we get to the end, I mean, it's technically okay, right? But what I mean is, are we allowed to not have variables? Yeah, because we have a true statement. So here is what that means. First thing that it means is that this is just a true statement. This side is less than this side. And if you're like, well, I don't see how. Well then, okay, give me a number. Let's plug in a number. Let's plug in a 1. So this would now be 4 minus 6, which is -2, right? This side is -2. And then this side over here would become 3 plus 1, which is 4. 4 minus 1 is 3. So this side is now 3. Is -2 less than 3? That's also true. So the idea is we could plug in any number. We could plug in 80 million and this would work. And so really here's the graph of something that's true. You just draw a line and you basically shade the whole thing. It's every number. It's all real numbers. It's -infinity to infinity. Okay? So that's why this one's special. Next, we have one we're going to simplify. 10h minus 3h is 7h. Plus 6 greater than or equal to 11 plus 7h. Subtract 7h from both sides, and they cancel again. But do not jump to, oh, it must be true. It must look like that, because it doesn't look like that at all. In fact, this is false. Why is it false? Well, because 6 is not greater than 11. So what does that graph look like? It's very complicated. Watch this. It's just that. We're done. You don't fill in anything because no number would satisfy this. What do I mean by that? Well, let's plug in a 1 again. This is now just 10 minus 3 is 7. 7 plus 6 is 13. 11 plus 7 is 18. 13 is not greater than 18. So, again, it's false. Number 10. Number 10 we get to have a little bit of fun with, kind of, I guess. Because the simplifying can look like this. I can divide both sides by 2. Those 2's cancel. This becomes 3 times t minus 1. So that's one option. Over here to the right, I'm going to scooch over. We could have distributed, and it would look like this. And, I mean, maybe you prefer this one because it feels a little bit more complete already, because you see that the 6 t's are going to cancel, leaving us with that. Oops, I scooched over a little bit. Didn't mean to do that. Whereas over here, we still technically need to distribute. And then now you can see, oh, well, these are going to cancel, and I'm left with -3 is less than or equal to -5, which is not true. This is also not true. So this whole thing is false. The answers are that. This kind of looks like fake, but it was supposed to say false. That just S got super squiggled up in there. 11, I'm going to divide by 3 on both sides. And I would get, by the way, 4x minus 2. So I'm going to go ahead and distribute the 4 to get 4x minus 8 is greater than 4x minus 8. Another interesting one, the x's will cancel, leaving us -8 is greater than -8. Nope. This one's false, and you know what? I'm not even going to graph the false. You know what it looks like. It's a blank line. Let's divide by 2 to give me 3 times 1/3 d plus 4. Distributing the 3, I get d plus 12. is greater than d plus 12. And in fact, wait, how is that happening? Remember, I divided by 2. This is also not true, which is to say it's false, and the graph is a blank line. And in fact, wait, why? Well, because d plus 12 will never be greater than d plus 12. Think of a number that you could plug in here. If you plug in 0, you have to plug in 0 there. So is 12 greater than 12? Is 12 greater than 12? No, it's not. 13. Well, I can't, or I won't divide by 2 this time just because 2 and 5 are, they don't have common factors. So instead, I'm going to distribute to get 20 plus 5y is greater than 2y plus 14. I'm going to subtract 2y to get 3 like that. I'm going to subtract 20 to get negative 6. Divide by 3 to get y is greater than negative 2. This one's not a special case. It is just a regular old case of I've got numbers. I have an open dot on negative 2, and I will shade to the right. I will shade towards numbers that are greater than negative 2. I'm going to divide by negative 4 because, unlike the last one, 4 and 8 do have a number in common, so they will cancel. This gives me negative 2, like that, and then now I'm going to distribute the negative 2. On the left, 2x minus 6. On the right, I'm going to distribute that negative 2 to get negative 6 plus x. I'm going to subtract x, and I get x minus 6 is less than negative 6. I'm going to add 6 and get x is less than or equal to 0. Now, one thing that I think is funny about algebra students is they get something like this and they freak out. They're like, you can't have that. They think you can't have x equals 0 for whatever reason. But I tell you, getting 0 is perfectly fine. What we've done now is 0, 0, negative 1, 1. We put in a closed dot on 0 because 0 is exactly what we hit, right? And we're going to shade to the left because x is all of the numbers that are smaller than 0, like that. The area of the rectangle, is more than 47 square meters. Find the possible values of n. So I have to be honest with you, I did this problem entirely with making a bad assumption. See how this says meters? That's what those are also. So really, I guess what I could have done is I could have written meters squared here. And then what I would have done next is this is the width and this is the length. Or you can switch them because it doesn't matter. We're going to multiply each of them no matter what. And what we would have had is 2 meters times 3n minus 5 meters. And what we would get is, 2 times 3n is 6n. And 2 times negative 5 is negative 10. And then that would have been meters squared. And then check it out, we would bring down the 47 square meters. And then what we're going to do is, I know this seems kind of weird, but we're just going to add, this meter squared belongs to both of those, right? So I guess technically I could get rid of, why don't I do that real quick? Let me get rid of the parenthesis here and here. And you know what, let's scooch over the 6n. N meters squared. So what we could do is we can add 10 meters squared to make this 57 meters squared, and then we would have 6n meters squared, and then we're going to divide by 6, and we would get n meters squared is greater than 57 over 6 meters squared. So that essentially this whole time, like that meter squared, if we had not written it down, we would have gotten the same exact answer. So 57 divided by 6, that's 9 something. Let me do the exact math. So let's see, 57 into 6, like I said, that's 954, so it's 9.5. 9.5. So up here, N is 9.5 meters squared. Okay, so again, why I said something about, like, let me be honest, you didn't have to write M at all, but just know that that's how it ends up working. Next, you must maintain a minimum balance of $50. So if you have to have a minimum of $50, your account needs to be greater than or equal to $50. And it says you actually currently have $280. And it says write and solve an inequality that represents how many $20 bills you can withdraw. Well, you can't, and then without it going below the 50. So 280 minus, not 50, minus $20. But how many $20 bills can you take out? I don't know. But it has to be greater than 50. And if you're like, wait, he just said, I don't know, and wrote down an X. Yeah, that's what you do in algebra. When you don't know, you write down X. So 20 times, how many times? I don't know. But this is how you could do this one. And then we could solve it. We could subtract 280 from both sides and get negative 230, right? And then we could divide by 20, and actually by negative 20, and we would get, let's see, again, I'll have to do some math. 230 divided by 20, this is 11.5. So that's the exact value. You could remove 11 $20 bills, because if you remove 11.5 $20 bills, well, you can't do that. And you can't, and as long as it's below 11, you're good. As long as it's less than 11.5, you're good. Okay, this last one, I also had to go back and redo it because I read it and reread it because I was thinking, well, whatever. And by the way, Frank, why is he telling this stuff? I want you to know that it's okay for you to not be flawless on some of these, especially on your setup. The bank charges an ATM fee of $2.50. Okay, so I was thinking it's $2.50 per transaction, per times you take out money, right? And then it says, like, right here's where I got lost, which is charged each time you withdraw $20. So I was going not real life. I was thinking, actually, no, it is that I need to go not real life. In real life, they just take away $2.50 one time. But in this goofy problem, they take away $2.50 for every $20 you take out. So here's what's happening. You have your $280, and there, if you subtract $20, then guess what? They're going to subtract $2.50, and you still need to have more than $50 in your account. So to simplify this, it's 280 minus 2250 is greater than or equal to 50. Now you subtract 280, which I realize my 280 here looks awful. Subtract 280 again, and you're going to get negative 2250. X is greater than or equal to negative 230. Just like what you had up here, it's just now it's going to be 230 divided by 2250, which is a little uglier. 2250, let's see, there's 2250 there, 500, so there's 2 times there. That's exactly 500. So you can take out, I mean, here's the answer. X is And hang on, I don't want to, I've gone too fast. What happens is when you divide by that negative, it flips that, right? So it's x is less than or equal to 10.2. So you can take out, and this is stupid because it's not real life, you can take out 10 times $20. So you could take out $200. So this is the answer, all of that, or just one of those, you get the idea. And now if you want, take a screenshot or pause or do whatever you got to do, here are the answers. One thing I'll say is that these say no solution, and what I had said was it was false. Well, that is basically the same thing, is no solution is what happens when it is false. Okay, is that when we graphed it, we graphed this, right? We said it's just a number line that's blank. Notice that there is no solution because it's false. So anyway, there was that. Let me know what questions you got.